Hello everyone, I welcome you all for the lecture series Data Science. In this series, we have already seen the importance of data science and the areas in which we can use data science and the data science process, what are the steps and how those processes to be approached and to understand or to analyze or to apply data science techniques. We need two programming languages. One is R language, another one is Python. In this course is dealt with Python programming language. In Python programming, NumPy and Pandas are very important to handle data science. In the previous lectures, we have seen NumPy, in the importance of NumPy and how it is useful in understanding data science process and a few processes like slicing, indexing, data manipulation, operations. We have seen the same thing we are going to do in the other data structure, which is Pandas. In Pandas also, we are going to see the same but in a different manner because it is used to handle large data sets. Okay, so let's enter into the lecture. Introduction to Pandas. So Pandas is a Python library used for working with data sets. It has functions like we can analyze, we can clean the data, we can explore the data, we can manipulate the data. So the Pandas has a reference to both panel data and Python data analysis. It refers both panel data as well as Python data analysis, and it was created by McKinney in 2008. Okay, so why we have to use Pandas? So Pandas allows us to analyze big data. With that analysis, we have to make conclusions based on statistical theories like mean, median, and the variance, how far it is, crowded at one place, or how far it is away from our focus. So for that we need statistical theory. So it is clearly dealt with that. Pandas can clean messy data sets. Okay, so if the data is clumsy, then it is used to clean the data, make them readable, presentable, and relevant. This is relevant to that. I mean, using sorting, we can group only age data, or we can group only the values or the date or the temperatures likewise. So it's a kind of say like for example, Amazon in a day they have different kind of sales. So it's a messy data. Okay. So using pandas, we can make them readable and relevant. Means we can segregate electronic sales and clothing sales, grocery sales, and the beauty product sales. So likewise, we can make them readable and relevant for anyone using pandas. And the relevant data is very important in data science. If the data is not relevant, suppose in age, if I enter 40 degrees Celsius, so this data is not relevant to age. So in that case, your pandas is used to give only relevant data. This is very important in data science. Let's see one example. So since we are going to use pandas library, so we have to import pandas as PD. So hereafter we are going to address this pandas library as PD only. So this is the data. So here, I mean, you have to use the flower bracket. So flower bracket opening and flower bracket closing. Okay, first open and close, and then inside, how many columns do you want? So here I'm going to use two columns. One is name column and age column. Both are string, so it should be in the quote. And then under name, I'm going to fill the name column. So for that, semicolon hereafter. Here also, if for age also semicolon, and under names open a bracket. It's a list actually. So Alice, Bob, Charlie, likewise the age. Okay, and score is also given. Uh, Now we have to convert this to a data frame. So pd dot data frame, and then which one we are going to convert with, that is data. Okay, so we can, if you use this command, use this code, then it will convert that data into data frame. So we have to print. Okay, and print data comma data. So you can put data as the title and you can print. Okay, so here three columns: name, age, score, and then all those details are filled here. So that is print. This is your df. Okay, and we can print like this as well, like data is name. So the same thing can be printed. Okay, And next one is what are the features of Pandas? So it's fast and efficient data frame object with default and customized indexing, tools for loading data in memory data objects from different file formats. So it's a tool like we can load different data like CSV, comma separated file, then Excel file. The difference between this is Excel we can do operations, but in CSV no. And JavaScript object notation, SQL. So all these formats can be acceptable by Panda. Data alignment and integrated. So here we can align the data, we can sort the data and integrate it. So it's built-in method. So in order to do alignment and integrated, so we have some built-in methods, and methods are used to handle missing data efficiently. And reshaping and pivoting is also possible. We can change the we can change the dimension, and we can convert the pivoting means you have to convert the wider data into thin data or thin data to wider data using stack and unstack. Okay, so there is special type of ratio where columns become rows and vice versa because wider to thin, thin to wider. And label based slicing. The label is given to each, so based on that we can do slicing, indexing, and we can take the subset. If it is a large subset, we can take the group. We can make a groups and we can take that subset to do the analysis. Columns of a data structure can be deleted, so you can delete or insert the columns, and then you can group the data for aggregation. Suppose if you want to find the mean for only particular group means we can group it and we can take the aggregation and transformations. And high performance. So the merging and joining is it has got high performance and time series functionality. So I'll show you two more examples for time series functionality. So this is one example. So here this one data frame. So here data is given, and then this is the index. So if the index is not given, it should be mentioned as 0, 1, 2, but index is given, so index is A, B, C. And then the data is already given. So just in the previous case, it is 0, 1, 2, 3 is there. But we have given a new index, so that is printed over here. And then one more data frame is, so in data frame, we have PD dot series as well. It's a single dimensional one. So we can convert PD dot to dot series 1020 and index is given. So which means you have to give index and the index is A, B, C and you can print it. The next one is PD dot series 5, 15, 25. Okay, so actually this is not, so suppose if I want to print S1, how does it look is, so it has 10, 20, 30 and then the index is AB, okay, and for S2 the index is B, C, D, the data is 5, 15, 25. This is how this PD dot series looks for S1 and S2. So now we have to add these two. Okay. So it will add based on the index. So it will look for A, you have 10, but there is no A value. That is why it is printing as NaN. Okay. Because there is no value in S2. And B you have 5 and here you have, so it is 25. And then C here 15, here 34, it is 45. And for D, you have data in S2, but you don't have data in S1, that is NaN. Okay. So this is how it works. Okay. Then let's see some examples for time series functionality. So what is time series functionality? How Pandas. Okay, one big example is creating time series data. That is, suppose if I want to record sales data or if I want to record temperature data over time, I can fix the date. From this date onwards, I need the data for 15 days or 16 days. And then you can use that to analyze. So we can make a calendar. So this is one important example which comes under time series functionality. So let's see that. So we are using two libraries, Pandas and NumPy. And first we have to create a data frame, or first we have to create a data range. The PD dot data range only you have to use. Data range is a function in that you have to give start on from which date you have to start, how many periods, okay, how long it has to go. The frequency is D for day, okay. So first it prints like 1, 1, 1, 24, and then it's for 7 days, so 2, 1, 24, and it's D124, 41 up to 7, okay? Because the frequency is date. So using this data range, we can create a data. And then on that date, so this is named as date. Okay, the title is, or the column name is date. So we have to give the date, and dates are given. Dates is these data. And next thing is we are going to fill the column, temperature column, and then we have to randomly, so np dot random, we have to randomly select the numbers between 15 and 30. So we can say 15 or 20 or 25. So likewise 15 to 30, and then how many data we have to generate? 7. So likewise you can generate the data using time series functionality. For this we are using data range, pd dot data range. Once if you give the start date and if you give the periods and the frequency, automatically it generates the calendar. Okay, so this is one example. One more time series functionality is resampling. Suppose if I want to analyze the data weekly or monthly, I can use Pandas. So again, same thing. First, we have to create a data frame, and then the date is already we have made. So date we have made. For example, the starting date is, so here's the data range. So date is actually uh, this should come in the next line. Okay, this is one code line. In this code, we have started the data from 1/1/24 up to 15. Okay, so we have to generate the data. Frequency is D, day. Okay, so from 1 to 15. And then in that, I have, so this is named as date. Okay, the column name is date. Then I have to create one more column, which is sales. In this sales, I have to give the figure from, I mean, between 100 to 500, I have to give 15 data. For example, 200, 300, 350. Likewise, I need to generate 15 data between 100 and 500. Okay, so with this, I can get the date. I mean, I can set the index. So this is the index. The date is the index for this, and here I can take the resample. So I can do for weekly. So since it is weekly, so in between 1 to 15, we have 2 weeks. 7 and 7 days, and so we have 2 weeks. And then from 1 to 7, you have to add and take the mean. Okay, so this is the average sales per week. This is also average sales per week, which is week 2. Okay, so likewise, using time series functionality in Pandas, we can do the analysis for weekly basis, monthly basis, likewise. Okay, these are the examples. And in Pandas, there are two types of data, structures. One is series and data frames. Okay, so first we'll see series. So series means it's a single dimension. We have one index series, and data frame means you have more than one series, and each in data frame you have multiple series, Pandas series. Okay, a series is a one-dimensional labeled array that can hold data of any type, integers, strings, other Python objects. Okay, whereas data frame is the Python data frame is a two-dimensional tabular data structure with rows and columns. It is similar to a spreadsheet or a table. The next one is, here first we'll see what is series actually. So Panda series is like a column. It's like a column in a table. It's a single dimensional array. It has fundamental data structures and commonly used for data manipulation. And these are the features similar to that indexing. We can see some operations, how to align and how to handle the NAND data. Not a number. NAND means not a number. Okay, we'll see one example. So here we can create Pandas series from list. So this is one list. If you want to convert this to a series, then just put p dot series of this list. Okay. So this is the output for this. So since the index is not given, but data is given 1, 2, 3, 4, 5 data is given, but index is not given. So it is assigned by default. And in the second case, we have to convert to a PD dot series from the dictionary. So here, the dictionary, the key value is acting as a index. So A, B, C, and then the values are 1, 2, 3. This is from dictionary. And then next one is from custom index. So we are creating an index. The index is A, B, C, D, E, and the data is. So these are the various ways we can create PD dot series. And then how do you index? So here, this is one data. I mean, this is one PD dot series. So in this, I need to know what is the list of zero. Okay. So once you convert into this, the list of zero is one. So one will be printed. And then next, once you convert from dictionary to a PD dot series, you have to take the element B. B is a key value. So two will be printed. Okay. So likewise, you can index a particular data in the Pandas series. Okay. So this is some vectorized operations like addition, subtraction. So for all these, we are taking two Pandas series because we need two things to do these operations. Just if you put a plus b, automatically it adds. So 6, 6, 6. So these are the output, and subtraction, multiplication, and division. This is a normal one. Okay, but since it is a single dimensional series, it's easier to do that. And how do you align? So here you have, I think this example we have already seen. You have A data, but there is no A data. That is why we cannot add these two. So it is NaN. And B you have, so B 2 plus 4 6 is added. And C you have this. This means 3 and 5 you have added. But D it doesn't have data in the series A. So that's why it is NaN. So this is one kind of alignment. Okay, then we'll see how to handle NaN. NaN means not a number, not a number. Okay. Suppose when you collect data, if the data is not there, data is missing, we can replace it with NaN. But we need to handle NaN because that is also part and parcel of the data science process. So we need to handle NaN. So this is the biggest challenge for any data science. How do you handle NaN? Okay. So for that, first we have to take the Panda series with the NaN. Okay. So 1 2 NaN and then NaN. So the suppose if you want to print this, the output will be 1 2 NaN and 4 NaN. Okay. The index is 0 1 2 likewise. So now first I have to check whether this Panda series has NaN values. For that you have to give the comment because yes is the data Panda series. In that is NaN. Okay, so do you have any NaN number? In the first one there is no NaN number, so false. Okay, because there is no NaN. And in the second number also no, so false. But third one is we have NaN, so it is true. Yes, we have NaN, and fifth also we have NaN. So except this third element and fifth element, all the things will give you false only because there is no NaN value. Okay, that is first. Second one is if you find NaN, then fill that with sorry, before that we have to check one more. Suppose if NaN is not there, sometimes it will be blank. So we have to check whether is there any null. Okay. So NaN is also treated as null, the same as before. So NaN is treated as null, so it is true. For others, it is false. Okay. Next, we have to, so we identified, we proved that there are some NaN values. But how do you handle NaN values? First thing is we have to fill the NaN values with 0. So wherever you find NaN value, that has to be filled with 0. So we found a NaN value in the third place at the fifth place. So the third place at the fifth place is filled with 0. So we have handled NaN using one method. Another method is you can fill NaN with the mean value. So we have to find out the mean value for all this, and that mean value is 2.33. So fill that with the, fill that in third and fifth place. So in that way we can handle NaN. Okay. So first we have to find whether the NaN is present or not, and then the second case whether the null value is present or not, and then in the third step is once you identify NaN and or null, then that has to be replaced with 0 or mean value, or if you have any other common customized value that has to be filled. Okay, you can use that method also. So we'll see one more example, one more NaN handling. So first we take a data with a NaN. Okay, so that is 1 NaN, 3 NaN, and 5. First we have to do, because this is also NaN handling, F, F fill means forward fill. So here you have 1. So the next data is NaN, NP dot, is the NaN value. The forward fill means the same one has to be filled here. Okay. So now after this, once we apply F fill, the output will be 1. Yeah, here it is 1. Okay. The next case, nan you have, but you have to use forward fill. So, because the forward means in this direction. So, the 1 is filled over here. Okay. Okay. So, the next data is 3, but followed by nan. So, this nan is filled with 3 because it is forward fill. So, this is filled. Okay. This is fine. If it is backward means, so here 1 is not an issue, but 3 has to be filled in this manner. So here 3. The nan is filled with 3, and then this nan is filled with 5 because it's a backward fill. So forward means you have to move like this, backward means you have to move like this. So first identify the particular number and the particular nan. So if the previous value is replaced by nan means that is forward. If the next value is replaced with nan means that is backward. So in this way we can handle nan values. Okay. Then next structure is data frame. So data frame is a two-dimensional data structure. So it is a two-dimensional, and it is like a table with rows and columns. It has three main components. One is data, which is stored in rows and columns, and which are labeled by index. So you have the index for rows as well as columns, and it contains the actual data. Okay, so it has data, rows, columns, and each row and column is indexed. Okay, what are the characteristics? So you have indexing, you have column operations, you have missing data handling, and you have grouping and aggregation. So we'll see one by one with the code example. Okay, first how to form a data frame. First you have to give the data as usual with the flower bracket, and for each column you have to give the name and the list. So name column, age column, city column. Now you have to convert it to data frame. For that the code is pd dot data frame of data. So this is how, see, name column, age column, city column, but the index is not given, automatically index is assigned. Okay, so this is your df1. Okay, in the next case we have data, and the columns are name, age, city. Okay, so in the previous case we have given the name along with the data, but you can give separately name, age, city. So this is the list, so you have, this will be printed. Since column name is given, the column name is given, so you can use either this method or this method, and both are same only, but a slight modification. Okay, so this is how we can frame a data frame. Okay, then how do you index the data frame? Okay, so for the first you need a data frame, so which is the name column, age column, you have column, so that is given over here, and we need to access only the names. Okay, so for that df, open the square bracket and give the name. So all the names will be accessed. So John, Alice, Bob. Okay. So to access a particular column, give the column name. And if you want to use location of 0 means the entire row, that particular, so row means this is 0th row, first row, second row. So if you put df dot location of 0 means the first row element will be displayed. So what's the first row element? John 25 and New York. John 25 New York. Okay. Suppose if you see, this is to access the row by labeling, by indexing. But if you want to access the row with the position, integer position means, so here df dot ilog of 0. So in this, the I when the particular location is, so here the output is John 25 and New York, because I have taken a column. In that column I have to index that with respect to integer position. Okay, so this is the row in which each element is indexed with the particular number, which is 0, 1, 2. That is what. So here I location means it will access the row with the label 0. If you give 1, the label is 1. I location is this first row by integer position. Okay, and next one is column operations. So these are the, this is one data frame. Column operation, I can change the column, or I can add a column. So now I want, so already you have column like name, age, and city, but I want to add one more column as salary. So I can just put df of salary and you can print it. So see, this is the first one, this is the updated one. Now I have to check how many of them have the salary greater than 50,000. For the DFS form and data frame, under that I need to access the particular column I cannot access the column like salary. I have to again address this DF. So DF is gender because the entire data frame I'm going to use. In that data frame, I'm going to access only the particular column. That is also data frame. They have to check whether it is greater than 50,000. So in this, which one is 50,000? More than 50,000. This guy, Bob. So you have to give that data. So Bob, name and age and the city and how much salary. So in order, so this is called as the operation, column operation. Then I have to sort. Sort values is a function. And I need to sort by age, but not in ascending order. So age 25, 30. So in this not ascending order means it starts with 35, 30, and 25. Accordingly, the names and city salary will be aligned. So this is one example for column operation. Then next one is how do you handle the missing data? So again, we have one missing data, convert into a data frame. So now data frame is here. This is my data frame. Okay. First, before to handle missing data, first I have to check is there any null data? Yes. So here you have in the entire column you have one null data. So that is it should print true. Okay. So let me check data. Okay. So the first one is false because there's no NaN data. And in the second row, you have data and no NaN, so it is true, true. In the third row, so there is no NaN value, so it is all false, false. But here, I think some mistake is there, but here it says NaN. NaN means so some number is there. There are two reasons. One might be because NaN is a float value, but since it is under this thing name value, so it is treated as false, or the data is maybe some name is there, so that is why it gives false data. Okay, false output. Next, I have to fill the data. Okay, so how do I fill? If you find any NaN value in the name, fill with unknown. If you find the age, then fill with 0. If you find NaN value in city, fill with unknown. So in this we have one unknown, and then this 1 0 1 0, but this is also NaN. I think because of the because since this is the float value, so you have mixed data type. So here this is string, this is float value. So in that case, it is treated this as a string only. That is why the same thing is replaced. It treats this as a name. Now it treats the name. I mean under names, it treats NaN as a name. That is why there is no replacement. Okay. Then again forward fill. So in the first forward fill, first 25. So here 0 you have forward fill means the previous data is filled, and here forward fill means New York is filled. Okay, and yeah, this is treated as the it is not NaN according to the name because it's treated as a string. And then backward fill means, so here is the NaN value, the backward value 35 is filled. Okay, and in this case the next city name is Chicago, so Chicago is filled in. Okay. Okay, so this is how we have to handle uh, missing data. And then one more thing is mean. Okay, so first we have to group by city. Okay, so you have to arrange in the ascending order. So city we have New York, so this has to be arranged in the ascending order. So we have groups, the Chicago, Los Angeles, and New York. Okay, under this you have to consider the age. Okay, so since the city names is not repeated, it is only one, so we can, so the single entry is considered as an average or mean. So 35, 30, and 25 is there. Okay. In the next case, so you have two New York, you have two Chicago. So in that case, if you want to find out the mean, first you have to group the city. So the city is first Chicago, Los Angeles, New York, because the repeated ones is removed. And Chicago, there is no, only one entry. Chicago is third. Chicago is for 35. One second. Yeah. Chicago is, yeah, we have two Chicago. So one is 35, another one is 45. So the average is mean is 40. Okay. Then next one is Los Angeles, only one. The data is 30, only one entry. So that is self a mean. And then for New York, we have two data. One is 25, another one is 40, which is 65. Average is 32.5. Okay. So in this way, we can handle the NaN data. So this is part one introduction about pandas. So in this we have seen what is the importance of pandas and then what are the important features. One such important feature is the time series functionality. Like if you want to know the data from this particular date, we can use it. Or if you want to analyze the data week wise, monthly wise also, we can use. Day first you have to fix the date and how to analyze accordingly. Then in pandas, there are two data structure. One is series, pandas series, and the one is data frame. This is single dimensional. This is two dimensional and more than that. And so in both in panda series and data frame, we can handle not a number. Okay. So how do you handle? First, you have to identify the presence. You have to confirm the presence of NaN by using is NA. Okay. Once you find, then one thing is you have to fill NA with either zero or any customized number or mean. Once you do that, then or the another way. This is one way of handling NaN. Another way of handling is you can use forward fill and or backward fill. Forward fill means the previous number will be replaced. Backward fill means the following number will be replaced. For example, this is NaN position which is n. Okay, the previous position is n minus 1. The next position is n plus 1. So for forward fill, n minus 1 is replaced. For backward fill, n plus 1 is replaced. Okay, so that's all for today. In the next lecture, we'll see some more operations of pandas that will be helpful in analyzing the data in data science. Thank you.